Let's now look at problem 6 from exam number 1, summer of 2007, and try to analyze it. What we're asked to do in this problem is find the power absorbed by R sub 5, that's this resistor, and we're to assume that all the resistor values are equal and that they're equal to 1. What we need to do then is find the current going up or down. It just seems clear to me that I might want the current going down through R sub 5. If I could find that current, then I could square it and multiply by R sub 5, and I would be able to find my power absorbed by resistor 5. We call that I sub 5 squared, and that would be in watts. What I need to do is find that current, and if I knew this voltage drop from top to bottom, I would be able to find the current. But that voltage would require that I write some KCL equations, and this circuit seems to be loaded with nodes. There's a node, there's a node, there's a node. Those may not be essential nodes, but they're still nodes. Here's an essential node, and here's maybe the reference node, and doing that I'm sort of overwhelmed with nodes, and so I don't think I want to write node voltage or use nodal analysis. What I'm thinking more that I can see the meshes there, maybe I'll write some mesh equations. Maybe I'll call this I sub 1, this I sub 2, and this I sub 3, and start writing some Kvl equations. Now I have 3 equations that I need to find and solve for I sub 1, I sub 2, and I sub 3. If I can find I sub 2 and I sub 3, then I can say that I sub 5, since I sub 2 is going with I sub 5 is actually I sub 2 minus I sub 3. If I can find those two currents, then I can use my power equation for the power absorbed by R sub 5, and I'm done, because I just square that current and multiply it by 1, which is the value for R sub 5. If I look at this a little bit more closely, I actually see that this current, the current source, this 4 amp current source, is actually the same as this current I've defined as I sub 2. And I'm then halfway there. I sub 2 is actually equal to 4 amps. That means there's one of my 3 equations. It's already basically known. I now know what I sub 2 is. Now all I have to do is find I sub 1 and I sub 3, which means I need to write 2 more equations and find I sub 1, or use those to find I sub 1 and I sub 3. That being said, let me start writing some KVL equations, and I would just say, well, if I'm interested in I sub 1 and I sub 2, I sub 1 and I sub 3, maybe I should just start looking at writing KVL with those particular meshes that I've highlighted in light blue. If I write a KVL around mesh 1, then I'm going into the minus terminal of my 5-volt source, plus R sub 1, I sub 1, plus R sub 4, I sub 1, plus R sub 2, and now I have 2 currents, 2 mesh currents acting in opposite directions through R sub 2, and then the direction that I'm going from right to left, I want my positive current to be I sub 1 minus I sub 2, and that should sum to equal 0. Since we already know what I sub 2 is, which is 4, and because all of these resistor values are 1, I'm now in a pretty good position, because now I just have one equation in terms of this one unknown I sub 1. Or I have I1 right there, I have another I1 right there, and I have a third I1 from this piece. I have a -5 and I have a -4, which if I add 9 to both sides will give me 9. I then have 3I1 is equal to 9, or I1 is now 3 amps. There was then one equation that was independent of I sub 3, and now I have two of my three unknowns. I now know that I sub 2 is 4, I sub 1 is 3. Let me now write KVL around mesh 3 and see if I can come up with an equation through which I can solve for I sub 3. I'm going to have R3 times I3 minus I2, go through the dependent source from plus to minus, so that will be plus whatever the expression is for that dependent source, which is actually 4V1, and then I'll come down through R sub 6, which will be R sub 6 times I sub 3, and I'm back to where I started. And the only thing I have to worry about then is solving for V1, or replacing this V1, but that V1 is up here, and it's defined, so V1, when I need it, is actually going to be R1 times I1. And R1 is 1, so this is then just I sub 1. When I find V1, or if I use that in an equation, I can replace it with I sub 1. Let me now write my mesh equation, or KVL, for mesh number 3. KVL at mesh 3 says I have R sub 5 times I sub 3 minus I sub 2 plus 4V1 plus R sub 6 I sub 3 is equal to 0. Or I now have I sub 3 from this. I now have minus I sub 2, and I sub 2, remember, we've already found to be 4. V sub 1, we just told ourselves, was actually I sub 1, wasn't it? If I can remember. V1 is I1, and we have 4 of those, plus we have another I sub 3 equaling 0. I sub 1, reminding ourselves that was 3. So this now is plus 12. Here's minus 4, and we have 2 I sub 3. All of those equal to 0. Or 2 I sub 3 is now equal to a minus 8, or I sub 3 is equal to minus 4 amps. The current then that we had defined as I sub 5, which was I sub 2 minus I sub 3, is now our I sub 2, which was 4, minus I sub 3, which is minus 4, or this current coming down from top to bottom through R sub 5 is actually going to be 8 amps. Our power then, absorbed by resistor R5, was R sub 5 I sub 5 squared. All of our resistors had a value of 1 ohm, We then need to square I sub 5 to yield a power absorbed by R sub 5 of 64 watts, and that's our answer.